Hey everyone! So today we are going to be learning about section 3.4, which is about carrying capacity. The learning objective for today is that you can describe carrying capacity and also describe the impact of carrying capacity on ecosystems. We'll be learning about kind of what causes a carrying capacity, how you can interpret it on a graph, what happens when populations overshoot that carrying capacity, and how the ecosystem impacts the carrying capacity of organisms. So these are going to be graphs that you will typically see when we talk about carrying capacity. And you will notice that carrying capacity has a little K behind it, and that's because carrying capacity is denoted by the K. That's what K represents. So carrying capacity is the maximum number of individuals in a population that an ecosystem can support based on limiting resources. There's not going to be an ecosystem where we have resources that go on forever and ever. So at some point, the size that we are going to have is going to be limited by what resources are available in that ecosystem. So when we are looking at these two diagrams, the one on the left-hand side, keep in mind, is kind of more of like a theoretical, where you have a population that's introduced. At first, it has all the resources it needs, and it's growing at a really exponential fast rate. And then eventually, they hit this point, which is the carrying capacity, and the growth kind of levels off and plateaus. But this is more of a theoretical. This isn't typically how we actually see the populations fluctuate. In fact, this second figure here is going to be more realistic, where we're going to see a population kind of fluctuating around this carrying capacity. We'll see the population kind of overshoot it, and then you'll have a bit of a die-off because there really weren't enough resources. And then they'll grow and they'll overshoot it again, and then you'll have a bit of a die-off. And so it's kind of this system that keeps repeating itself. And this is typically going to be more of a graph that you will see when we're looking at actual population numbers from the real world. So from these types, you kind of have to estimate the carrying capacity, sort of based on like the middle area where it seems like an appropriate handling of that population number is going to be in the ecosystem. So it's often a little bit of an estimate based on what we're seeing with population numbers. So again, carrying capacity is going to be the highest population size that an ecosystem can support based on limiting resources. Now, limiting resources are just going to be environmental factors that limit growth. And these can be things like the amount of food that's available, the amount of water that's available, the habitat, like how much space there is. For birds, maybe it's nesting sites, or maybe for wolves, it would be den areas. So it's just going to be kind of a wide range of things that can impact it. Now, when we are talking about the fluctuation of those populations, the overshoot is going to be when a population briefly exceeds its carrying capacity. So an example of this might be deer breed in the fall, and then they give birth all at once in the spring. So you're going to see like a sudden spike in population that maybe the ecosystem isn't actually able to handle, but because they were all born at once, we're seeing that instant population growth there. Now, the problem is when you have this overshoot, the resources are depleted. So for this deer example, if we're having too many fawns, then we're going to have overgrazing, which means there isn't going to be enough grass to feed everybody. And that's going to be a consequence for that deer population. And what will occur is die-off. And this is when you have a sharp decrease in the population size when resource depletion, that overshoot, leads to many individuals dying because you just don't have enough resources to go around. So continuing with this deer example, if you have too many fawns who are feeding in the spring, then you're going to have quite a few deer who are going to starve because there just is not enough grass there. And that's going to be when you see the drop, which is going to be a die-off. Now, die-offs can even be really consequential if you have quite a few or quite a lot of the resources just completely used up. And one of the examples that we can see is with the reindeer population on St. Paul Island. So back in 1910, 25 of these reindeer were reintroduced to this island. And at first, if you look at the graph here, the growth was gradual from about like 1910 to 1930. It's increasing, but it's doing so at kind of a gradual rate. And then we see from about 1930 to 1937, this exponential growth that just skyrockets. Now, clearly the carrying capacity was overshot. The ecosystem could not support these 2,000 reindeer here. And because it was overshot so badly, it completely crashed to almost 0 individuals. There were technically like 8 of them left in about 1950, but majority of them died off. And this is because reindeer feed on lichen during the winter, because that's one of the only types of foods that they can eat that's available in the cold months. And lichen grows really slowly. So when you have these reindeer in the winter trying to survive off of the lichen, and 2,000 of them are wiping that out, the lichen's not going to recover in a few days. It's going to take a long time for that lichen to come back, which means for those winter months, there's no food left once it was completely eaten, and most of them are going to starve and die off. Now, once there were 8 here, we did end up seeing the ecosystem recover, and now the population exists on St. Paul, and it's more at about like 400-ish. So they were able to come back from this, but sometimes you just lead to the extinction of a species in an area if the die-off is so bad. And this is just kind of like a reminder that populations don't always fluctuate around a carrying capacity. You can have these times where resource depletion is so severe that populations totally crash. So it's not always just this even little fluctuating around a line. Sometimes it's not good and it just totally crashes and there aren't resources for it. Now, we can also look at carrying capacity with predator-prey graphs when you look at a predator and the prey that it eats. So an example of this is going to be with hare, which are like snowshoe hare, like rabbit, and lynx, which are a big cat species. And these numbers have actually been tracked pretty consistently up in Canada, where you mostly find these. And it's important to remember that the predator and prey interactions affect the population sizes of each species. So for the lynx, we're talking about this limiting resource of food. And then for the hare, predators can be a limiting resource as well. So if we kind of look at different points on this graph, the hare is going to be the purple line and the blue is going to be the lynx. So we first see here at number 1, the hare population is increasing due to low predator population. So if we look here, the lynx are pretty low. So we start having an increase in hare. Now at about number 2 right here, which is the 2 on the blue line, you start seeing the lynx population increase due to an increase in food from the hare. So now they're starting to go up because they have a bunch of food available to them. Now at number 3, we start to have an increase in lynx population starts to limit the hare population, which leads to a die-off in the hare. Then number 4, the next step for the lynx would mean that that hare die-off decreases the lynx food source, which starts leading to the lynx dying off. And then number 5, we're going to do it all again. When the lynx numbers are low, the hare numbers are going to go up. And then you see that this cycle just kind of is going to continue itself. And this is typically what we see with a predator-prey graph with the interactions that they have with each other. And again, this is because we have the limiting factors of predation or food, depending on which species we're looking at. And if we were to use this to kind of estimate a carrying capacity, again, because it sort of fluctuates around it, I would estimate that the hare population is probably at a carrying capacity of about 60, because we're kind of seeing it once it overshoots that, it doesn't do well. Or maybe you estimated it about like a 50 or somewhere around there. Again, it is sort of an estimation on it. Now, when we look at the lynx, I would estimate that their population number is probably going to be down closer to like 30,000, because these are in thousands. So this is going to be, if we look at about 30, that's where it's kind of fluctuating around. So that would be my estimate of where the lynx carrying capacity is going to be. So this is your FRQ practice 3.4, and the skill that you're going to practice is explaining what the data implies or illustrates about an environmental issue. So this graph shows us what happened with wolf and moose populations when the wolves were struck. Wow, sorry, I'm struggling over my words here. When the wolves were struck by a canine virus that, as you can see, decreased their numbers. So what I want you to do is to explain the impact that the canine virus had on the moose population based on the data that you get in this graph here. So that will be your FRQ practice for 3.4. Those were your notes on section 3.4 about carrying capacity.